Alright guys, so in this video, we're going to summarize what we went over in the past 3 videos. And hopefully this little short sentence right here. I'm going to try to summarize everything we talked about in the last 3 videos pretty much in this video. Alright, so introduction to rigid transformations summary. Okay, so here's the summary. The summary is if you have an object or a figure in the xy plane, okay, this is the xy plane, also known as the coordinate plane, okay, so this is going to be the same thing for this class. The xy plane and the coordinate plane are going to be the same thing for this class. And you translate, rotate, or reflect the object or figure in any sort of way, then the length of the sides of the object will not change. The measures of the angles for the object will not change. And if the object has parallel lines, those lines are going to stay parallel. All right? So let's look at this example. Okay? So at first glance, this looks a little long, okay? But if you dive into it a little deeper, then you can see that it's just it's more conceptual than it is tricky, okay? So let's read it. Let's go ahead and read it. It says, a square on the coordinate plane has the points A 22, B 26, C 66, D 62. Plot the square on the graph. Okay, we're going to go step by step. Okay, so let's do this first. It says the point A of the square is at 2, 2. So how do you plot that? Well, you just go over 2, up 2, put a point. Okay, the next point is B 2, 6. You go over 2, up 6. So right here. The next point is C, which is 6, 6, over 6, up 6. And the last point, D, over 6, up 2, 6, 2. So you go over 6, up 2. All right, so now if we connect those dots, you can see that we get the square. Okay, now let's call this square this little square here. Okay, let's just assume that this square is that square. All right, so now what's it say? Well, now it says if you rotate the square 180 degrees, how long will one of its sides be? Okay, well, the key word to notice here is what? The key word to notice here is rotate, right? Rotations are one of our rigid transformations. It's one of the transformations that doesn't do anything to the length of the sides. It doesn't do anything to the measure of the angles. It doesn't do anything to the parallel lines, okay? So it says, if you rotate the square 180 degrees, how long will one of its sides be? Okay, well, let's go ahead and do that. Let's rotate this square 180 degrees. Let's say we rotated it maybe like this. Maybe we'll go, or maybe we'll rotate it over the y-axis 180 degrees. Okay, so now it looks like that. As you can see, the length of the sides didn't change, right? So we started off with this square, okay? What's the length of this square? Well, the length of this square is you go over to the 2, and you see it starts at 2, and it goes to 6. So that means this length here is what? 4, okay? And what do you know about a square? A square has all equal sides. That means this length is also 4. That means this top length is 4, and this length is also 4, okay? And we're being told that it's being rotated 180 degrees. How long will one of its sides be? Well, rotations, the length of the sides of the object will not change. So it's kind of like a trick question. It's kind of like it's just a very straightforward question. If you rotate this square 180 degrees, how long one of its sides going to be? Well, the sides are still going to be 4 units long because rotations don't change the length of the sides. Okay, that's pretty much it. Okay, so the answer to this is just going to be 4 units. All right, that's it. Let's look at the next one. The next one says, if you translate the square 10 units to the right, how long will one of its sides be? Well, what's the key word here? The key word here is translate, right? What do we know about translations? Well, when you translate, it's this the same properties hold for the other rotate and reflections. So when you translate, the length of the sides of the object will not change. The measures of the angles for the object will not change. Parallel lines stay parallel lines, okay? So here we're being told if you translate the square 10 units to the right, okay? So let's say we have the original square here. So if we take the original square, translate the square 10 units to the right, that means slide the square 10 units to the right, okay? And if you do that, let's say we're here, okay? Let's just assume we're there, all right? How long will one of its sides be? Well, the length of the sides of the square isn't changing because we're just translating. And translations don't change the length of the sides. So the answer for this one is still 4 units. All right? Next one. It says if you reflect the square over the y-axis. Okay, so here we are here. Okay? And it says if you reflect the square over the y-axis, how long will one of its sides be? Well, what do we know about reflections? Reflections do not change the length of the sides. So if I reflect this square over the y-axis just like this, okay, let's say that S, let's say that's a hideous S, but let's say it stands for square. And as you can see, the length of the sides of this square is still 4. Why is it still 4? Because rotations don't change the length of the sides. So all of these are pretty much trick questions. They're not trick questions, but they're testing to see if you know a concept, okay? And the reason they're worded so superfluously is so you get familiar with the test, with how the test is going to be worded, okay? So the test is going to be worded like this, but as long as you know that rotations, translations, and reflections don't change the length of the sides for a figure or an object, then it's just a straightforward problem. You just know that the answer is just going to be the original length of the square. Okay? So justify your answer. Pretty much all you could say here is rigid transformations, which is what we're doing, which is what rotations, translations, and reflections are. Rigid transformations preserve the length of sides, okay, or the length of the lines, okay, it doesn't change. All right, let's look at another one. This one says a line segment that is located in the first quadrant is 30 meters long. All right, so real quick, let's go see what the quadrants are. Okay, you guys may have forgotten that. It's okay. All right, so real quick, the quadrants are, this is the first quadrant. Okay, so we call this one quadrant 1. Quadrant 1. We use Roman numerals to do it. Okay, quadrant 1 is this one. Okay, this positive. This is going to be quadrant 2. Okay, this is going to be quadrant 3, and this last one is going to be quadrant 4. Okay, and what are we told? We're told that we have a line segment. Okay, if you guys don't remember what line segment means, line segment is just a piece of a line. It's a line that ends. Okay, so it's a line with 2 endpoints. Okay, so it's just a piece of a line. That's how I want to define it. Piece of a line. Okay, it's just a line that ends. All right, and we're told that it's located in the first quadrant and it's 30 meters long. Okay, so pretend this is the line that's 30 meters long. All right, so here's our line that's 30 meters long. And what are they saying that what are they saying that we're doing? It says if you reflect the line segment over the x-axis, how long will the line segment be? Okay. Well, what do we know about reflections? Right? Reflections do not change the length of the sides of anything. Okay, so in this case, the reflection is not going to change the length of the line. Okay, let's pretend this is a line here. All right, so it says if you reflect a line segment over the x-axis, okay, so if I reflect it over the x-axis, remember this is the x-axis, okay, if I reflect it over the x-axis, what do we get? Well, the length of the side still doesn't change, okay, so it's saying how long will the line segment be? Well, the line segment's going to stay 30 meters, okay, so it's still going to be 30 meters even if we reflect it over the x-axis. Again, the question is just understanding, is just seeing if you understand that reflections preserve the length of lines. Okay, and it does. Okay, so the answer here is just 30 meters. It doesn't change because it's a reflection. Okay, now what's it saying? It's saying if you rotate the line, okay, let's go to the next one. It says if you rotate the line 90 degrees counterclockwise, how long will the line be? Okay, so we're back in quadrant 1, okay, where we started. It says if you rotate the line 90 degrees counterclockwise. Well, counterclockwise is like going to the left, going to the left like this, okay, and that's 90 degrees. So you could kind of think of it like maybe, let's say, hands on a clock, right? If this is like 3 o'clock, then 90 degrees would be like 12 o'clock, okay? So if you rotate the line 90 degrees counterclockwise, how long will the line be? Well, rotations don't change the length of the line, okay? So even though we're rotating, okay, we know rotations don't change the length of the sides. In this case, it's the length of the line. So how long will the line be? Well, the line's going to stay 30 meters. Justify your answer, okay? If you want to justify your answers for this, we can just say rigid transformations preserve. Maybe on this one we'll say they preserve distance. Okay, because the distance between none of these objects is changing. It's all staying the same because we're reflecting and rotating. And in the other case, we were translating. All right. So let's look at this. Let's look at this question. This next one. All right. So this next one says. Now this next one says, let's say there's 2 line segments located somewhere in the coordinate plane. Okay, there's 2 line segments located somewhere in the coordinate plane anywhere. And so anywhere in here. Okay, let's say one of the line segments is 200 units long. Okay, here's a 200 units long line segment. Okay, let's just pretend this is a line. Okay, and the other line segment is 50 units long. All right, maybe we'll go like this. Okay, here's the 50 units long line segment. Okay, so here's the 200 units, here's the 50 units. All right, and it says if we rotate these line segments, keyword here, 90 degrees. Okay, so let's do that real quick. If we rotate these line segments 90 degrees, maybe they look like this now, and we translate, and then it says, and then translate, okay, another keyword, each one 50 units to the right. So let's say that's 50 units to the right here, okay, and there's another 50 units to the right. Let's just pretend, okay, and then it says, and 25 units down. So maybe this is 25 units down for each one. What will the length of the lines be? What will the length of the line segments be? What will be the length of the line segments? Well, as you can see, they didn't change. The length of the lines didn't change because we rotated and then translated. These are rigid transformations. They preserve distance. They preserve the length of lines, okay? So they didn't change. So the answer here is 200 units. It's the one that was 200 units long stayed 200 units, and the one that was 50 units long stayed 50 units. Okay, that's it. Justify your answer. Rigid transformations preserve distance or length of lines. Okay, guys, so that's pretty much what these questions were asking. They were just asking you to do, a bunch of rigid transformations, and for you to notice that none of the lengths, the size didn't change for anything. Everything stayed the same. Okay, that's pretty much what these questions were asking. All right, so that's going to be it. In the next video, we're going to move on to the next topic. I hope this makes more sense. If not, feel free to ask questions. All right, thanks for watching.